Hi, I'm Alex from the Zscaler Customer Success Engineering team. In this series of short videos, we're taking a look at the baseline recommendations for configuring the cloud firewall policy inside Zscaler Internet Access. This is Part 6, DNS Control. DNS has emerged as a key front line in the war against cyber threats. Typically, organizations lack controls over requested domains and responses. Evolutions in DNS, such as DNS over HTTPS, also allow for out-of-site DNS resolution. This results in an increased risk. Malicious threat actors can leverage DNS and DNS over HTTPS to exfiltrate data or send encrypted command and control instructions. According to Threat Labs research data for 2024, nearly 90% of organizations globally have experienced at least one DNS attack in the last 12 months, and the average cost incurred for each attack was over $1 million. To help combat this, Zscaler's DNS security and control module includes DNS tunneling detection. This leverages a machine learning model to detect DNS tunneling by looking at variations in data amount, variations in requests for subdomains, number of requesters per domain, and authoritative NS reputation. This module also leverages the cloud effect. This means that when DNS tunneling is detected for one customer, all Zscaler customers benefit from this detection, and these DNS tunnels can be blocked. Another benefit of routing your DNS traffic to Zscaler is enabling you to have high availability and inline optimization. Here, we have an example user situated on the west coast of the United States with a corporate headquarters in Atlanta. Under a common centralized architecture, the user's traffic is routed back to Atlanta from their location in San Jose, leading to lots of hops, low performance, and high latency. With DNS optimization enabled, traffic is directly routed to San Jose with a single point for access control and visibility, and ECS supported. Enabling this DNS optimization only requires toggling the optimized DNS resolution setting into advanced settings. Finally, here are some general guidelines for addressing threats from DNS traffic. First, it's important to protect users from reaching malicious domains as the first line of defense. Where appropriate, DNS requests should be blocked using the protocol criteria, and DNS over HTTPS should be redirected to a trusted DNS server. Note that this requires SSL inspection. It's also recommended that you leverage DNS control policy to block DNS tunneling traffic to unwanted and commonly blocked applications, and that you set up trusted DNS server IP destination groups and allow DNS requests only to those trusted servers, blocking or redirecting any other DNS requests as the final policy, thereby securing DNS resolution and preventing DNS poisoning attacks. Here, you can see an example policy built according to the criteria we've just discussed. Rule number 1 blocks malicious domains, protecting users from reaching malicious domains as the first line of defense, by blocking DNS requests. Rule number 2 redirects DNS over HTTPS to a trusted DNS server. Rule number 3 blocks DNS tunneling traffic for commonly blocked applications. Rule number 4 allows DNS requests only to trusted DNS servers. And the final rule is a global redirect requests and keep sender protocol rule that redirects all other DNS requests as the final policy. Next, let's take a look at specific recommendations for building your DNS policy. First, it's important that you block unsafe DNS traffic. Zscaler tenants contain predefined rules that target risky, high risk, and critical risk DNS categories and tunnels. By default, on new tenants, these are enabled, but if your tenant is old enough, you may find that these are disabled by default. This was done so that when these rules were added in 2024, changes would not be made to production tenants without administrators making a conscious decision to enable these rules. DNS tunneling can be leveraged by attackers as a traffic obfuscation mechanism in order to exfiltrate data or establish and maintain C2 channels. Enabling these rules will block suspicious and known malicious destinations for DNS traffic, as well as blocking DNS tunneling, thereby eliminating this risk. Note that the high-risk DNS categories rule includes newly registered and observed domains and newly reactivated domains, which are often used by threat actors to stage malware campaigns. The critical risk DNS categories and tunnels rules also includes known malicious tunnels and known malicious DNS categories. Next, it's recommended that you also block unknown DNS traffic. The unknown DNS traffic rule is a pre-configured rule that acts on suspected malformed traffic, non-standard DNS traffic, and non-DNS traffic attempting to conceal itself as DNS traffic, which is not otherwise identified as another application. By enabling this pre-configured rule, you'll block this unknown DNS traffic, reducing your attack surface. Finally, it's recommended that you enable DNS optimization settings inside advanced settings. These settings include the optimized DNS resolution toggle, and the Enable ECS options for locations and remote users toggle. Both of these default to disabled, but should be enabled. By enabling these settings, when an initial request is received, ZIA will perform its own DNS resolution and override the destination IP if the received and resolved destination IPs are different. Note that this optimization is not performed over DNS packets. The resolution is based on the HTTP header or SNI field. ECS, or ADNS client subnet, is a standard option within DNS packets that allows DNS servers to respond with the IP address closest to the requester. Both of these in combination will ensure that your users get a quicker, optimized DNS resolution when browsing the internet, improving user experience. That's it for this video. Thank you for watching.